topic 12.4, page 824.
Oh my goodness, what is this?
So when it gets messy, what's my rule of thumb? I help you do the first one.
That sounds good.
So problem number 1 says Farmer Brown has planted a field of experimental corn, and there are 20,000 plants. So I come over here and I put 20,000 plants. Okay? And a graph of their height looks like that shown in the figure below. So, in this picture, and I have this picture up here, we're going to use this over and over again. So you just, and the picture shows 100 here, right? And then it shows 110 here, and then 120 and 130. So over here it would be what? 90, 80, and 70. Okay? Now let's read what the questions are. What's the mean height of Farmer Brown's corn? Okay, see this information from page 818? The mean is right in the middle. So what's the mean height of his corn?
100.
100. What's the standard deviation from the mean? So the mean, or also written like this, is 100. The standard deviation, what did I add to 100 to get here?
10.
So the standard deviation is 10. That's why this is the mean plus 1 standard deviation, the mean plus 2 standard deviations, the mean plus 3 standard deviations.
Okay.
Okay? What percent of the corn stalks is between 90 and 110? So from 90 to 110, what percent? And see this from page 818? You need to have that information right beside you where you can look at it while you're working the problems. So 0.34 and 0.34, one standard deviation above, one below. So what do you think happens if I add 0.34 and 0.34? 0.68, which would be what? 68%. Everybody follow that? This is a normal curve.
Okay.
Then what's it say next? How many stalks are between 80 and 90? So now they come back here and say, what about 80 to 90? And what does that say? 0.135. Is that right?
What?
Yes.
Oh, yeah.
0.135 from 2 standard deviations below to 1, 80 to 90. And what percent would that be? 13.5%. Okay?
Is that the answer? I said how many stocks.
Oh, so it's 13.5% of 20,000. Because they want to know how many stocks. And what do you get?
2,700.
How many?
2,700.
2,700 stocks. And can you see, you can rough this out, 10% would be 2,000, and 3% more would be about 2,700? Or,
That's what it says in the back.
yeah, that's right. Because if you take 13.5 or 0.135 times 20,000, you get, yeah, 2,700. All right? So you see how this information from page 818, you don't have to have it in your head, but you're going to have it laying beside you somewhere.
Mm-hmm.
So you can keep looking at it. And this information from page 822, you're going to need that information too. So that's why I put it over here, so we can keep looking at it while we talk about it. Okay, do you understand question 1?
Kind of. Yeah, I think so.
Let's do question 2. What does question 2 say? So now I erase all of this, and all of this, and all of this, and the 20 plants, and I erase all of this. But I don't erase this information here, because see how it stays the same all the time? Suppose you were informed that the annual income of lawyers is normally distributed. Okay, as soon as they say that, this is a normal distribution. So when they say the salaries are normally distributed, then what does it say next? The mean is 40,000. So what number goes right here? 40,000. Let's just write it like this. Let's write it like this. 40,000. You follow me? Then what does it say next for problem 2? The standard deviation is 10,000. So what number goes here?
10,000. No, 5.
50,000. What number goes here?
60,000.
60,000. What number goes here?
70,000.
Everybody follow that?
Mm-hmm.
So what number goes here?
30,000.
And here?
20,000.
And here?
10,000.
See, because it said normally distributed, I used this picture and I put down the mean and then I put in the rest of the information. Because they said the standard deviation was 10,000. Question A. What would you estimate for the percent of lawyers with incomes over 50,000? So how many lawyers have an income above 50,000? Did they say what percent or how many?
What?
Percent. Percent above 50,000. Here's 50,000.
Mm-hmm.
What percent is above here? Where is that?
34. Wait.
0.135, right?
Mm-hmm.
And 0.025. So I add those together. Do you follow that?
Mm-hmm.
Okay, above 50,000 would be everything on this side of this line.
Mm-hmm.
What percents are on this side of this line? 0.135 and 0.025. So I add those together. 0.160 or 16%. So 16% of the lawyers make more than $50,000 a year. Ah. So you mean all those people thinking I'll go to law school and I'll get rich? Most of them are going to be making money down here at this end. There's only 16% that's going to make money up above that. And up above 60, it's even smaller. Only 2.5% of those people. There's only a few lawyers who really make a lot of money. The rest of them use their legal skills to work for a company and make what other people normally make. Okay. Question B, what percent of the lawyers would you estimate have an annual income of less than $20,000? Okay, so now it says less than $20,000. So now we're going this way. And it says percent less than 20,000. So what would that be? Look back at the chart. What number is right? What number is from here this direction? 0.025. So what would that be? 2.5%. You follow that? Question C, if a lawyer is selected at random, what would be the probability that his annual income was more than $60,000? Okay, now we erase this and we come up here and we say more than 60,000 starts here and goes this direction. And what's the probability of a salary? Did it say what percent? No, it said what would be the probability that his annual income would be more than 60,000. Out of 100 people, how many of them will have a salary above this? 0.025. Is that right? From that picture on page 818. So that would be 2.5%. Would have an annual income of more than $60,000. Because it said these salaries are normally distributed. So when it says normally distributed, this is the information that we use to answer the questions. So you understand question 2? Oh, we didn't do D. If the information given here were correct, would you think it very likely that 50% of all lawyers have an annual income of over $50,000? Do 50% of all lawyers have an income over $50,000?
No.
What?
Wait.
No, what'd you say?
Wait. I said no.
No, because 50% would have a salary over 40,000. Over 50,000, it's only going to be what? 0.135 and 0.025. 16% are only going to have salaries over 50,000.
Yeah.
And if it said 50%, it would have to be from the middle on up, and that would be from the mean, which is 40,000. So, let's do problem number 4. So watch what I do. still leave my picture here. I just erase all of this. And I look at problem number 4, and it says, for a certain standardized placement test, the kind you'll be given your little chippers, it was found that the scores were normally distributed. See that key operative phrase there? Normally distributed means it fits this pattern here.
Mm-hmm.
With a mean of 200, so I put 200 right here, and a standard deviation of what? $30. And I had 1,000 students. Isn't that what they told me?
Mm-hmm.
How many are expected to make scores between 170 and 230? Now see, I can't answer that till I finish my picture. So what goes here? Standard deviation of 30. That means this is 230,
Mm-hmm.
and this is 260, and this is 290. You follow what I'm doing?
Yeah.
And this is 170 and 140 and 110. So I use the mean and the standard deviation to fill in the values on my chart. And now, how many are expected to make scores between 170 and 230? From here to here. What is that? From here to here is what percent? 0.34. From here to here is what percent? 0.34. So what percent of these students would make a score between 170 and 230? %68. But now look what it said. See, this is where it said how many. So when it says how many, I have to take 68% of the number of students, 1,000. So what's 68% of 1,000? 680. So out of these 1,000 students, 680 of them will make a score between 170 and 230. How many are expected to score above 260? How many are expected to score above 260? And it says how many. So the first thing I say is, what percent will score above 260? And what's the answer to that? 0.34. This is 0.135. And this is what? 0.025. So that would be 2.5%. You see that? See where I'm getting my numbers?
Yeah.
What are you having trouble with?
No, I was just thinking about how to find percentages.
How to what?
How to calculate a number from a percentage.
So 2.5%,
Mm-hmm.
and it says how many, that would be 2.5% of 1,000 students.
So would you multiply or divide?
Of means times.
Of means times. That's good to know.
Doesn't it? Of means times.
You say so. It says.
Forgot that.
How many eggs do I have if I have 3 dozen eggs? I have 3 of them, and each one contains 12. So of means multiply.
Okay.
So I take 0.025 times 1,000, and I get and then 3 decimal places. 25. Whoa. How many? 25. Is that right? Let me check and see. Which one is that, number 4? Yep, 25. So what's the next question for number 4? What's the expected range of all the scores? Where do I expect to find 100% of the scores? Let's erase all of this. Erase all of this. Erase all of this. Erase all of this. What happens if I add, see this 100% here? From here to here. So what would that be? From here to here would be 100%, wouldn't it? Because if you add all these numbers up, 0.025, 0.135, 0.34, 0.34, 0.135, 0.025, it comes up to 100. So what did they ask for 4C? What's the expected range of all the scores from 110 to where? To 290. Everybody see that? The highest score I can expect anyone to make is 290. The lowest score is 110. You go, how did you get that now? The mean was 200 and the standard deviation was 30. So I used that information to fill in my chart. You see that? So let's do number 10. An experiment consists of tossing 100 dimes. So I erase all of this information, and now I have 100 dimes. And what does it say next for number 10? The graph of the heads turns out to be very nearly a normal curve. We're looking at number 10. With a mean of 50 and a standard deviation of 5. So the mean is 50 and the standard deviation is 5. So fill in the rest of the chart. What's this number? 55. What's this one? 60. What's this one? 65. Everybody see where I'm getting those numbers? What's this one? 45. What's this one? 40. What's this one? Does everyone see where I'm getting those numbers? So now that I've filled in the chart, I can answer the questions. Within what limits would you expect the number of heads to be 95% of the time? See that chart from page 818? 95% of the time, it's going to be between here and here. You see what that chart tells me? Because 34 and 34 and 0.135 and 0.135 add up to 0.95. So, what's the answer to the question? Within what limits would you expect the number of heads to be 95% of the time? Between 40 and 60. Do you see that? You understand what we're saying?
Mm-hmm. Mm-hmm.
And see, I had to fill this in before I could answer the question. That's a 60, not 66. Then what's question 10b? What percent of the time would you expect the scores, the heads, to be between 45 and 55? Now they're saying, what about between 45 and 55? What percent would that be? And the answer would be, what's 0.34 and 0.34?
0.68.
68% of the time.
Oh, okay.
Or, yeah, 0.68, but when they say what percent, then I change it to 68%.
Mm-hmm.
But if I wanted to know how many dimes would fall between 45 and 55, I would take 68% of 100 and come up with 68. Suppose a particular dime arouses your suspicion by turning up heads too often. You toss this dime 100 times. How many times will you have to turn up heads in order for you to be almost 100% certain that it's not a fair coin? How many heads will I have to get? 100% should fall between where? 100% should fall between 35 and 65. Agreed? So if this dime that I flipped 100 times, if I get more than 65 or less than 35, what would I say about that dime? It is not a fair coin.
That's good to know.
Because 100% of the time, if it was a fair coin, I would get between 35 and 65 heads. All right. Let's jump over here to page 826. And let's look at z-scores. Can you see what I have written here? Z is the number of standard deviations that X, the score, is from the mean. That's from page 822. Number 16. In a certain normal distribution of scores, so I erase all this because I'm working a new problem. And what do I put up here for number 16? The mean is 10, so 10 goes here, and the standard deviation is, did they say 2? Is that what they said?
Mm-hmm.
So let's fill in the chart. So what number goes here? 12,
Mm-hmm.
14, 16. What goes here? 8, 6, and 4. Everybody agree?
Yes.
Now, number 16 says, find the z-score for 11. Is that what it says? For a score of 11. So where's 11? Right here. Here's 11. Agreed? Right halfway between 10 and 12?
Yes.
So, what's the z-score? In other words, watch this. If I run this on up here where it crosses this line, what's the number right there for a z-score of 11? You go, the number of standard deviations that it is from the mean. And how do I find it? I take the score, 11, minus the mean, which was 10, divided by the standard deviation, which is 2. So, what does that say? 11 minus 10 divided by 2 would be what? 0.5? Is that right?
Yes.
So it's 0.5 standard deviations above the mean.
Mm-hmm.
Yeah, from the picture, 10 to 12, 11 is right there in the middle, halfway between, and that corresponds to this point right up here. And if you want to know what that point was up there, in the back of your book, on the very back page, on the back cover, there's a picture that looks just like this. Look at the back of your book, and you'll see it. Now what's this? Come down the left.
I like this.
Come down the left-hand side of the column till you get to 0.5, and then go across the top to 0. And what number do you come in contact with?
0.191.
0.191. So there is the probability right here. In other words, what can I expect? How many people can I expect to score between 10 and 11? 19%. You go, but I thought that was 50%. Yeah, but how many are going to score between 10 and 12? 34%? Well, wouldn't halfway be half of that? It would if it was a straight curve. You follow me? But because it curves, it was a straight line, but because it curves, it's 19% are between 10 and 11. So, how many students are going to score between 10 and 11? 19% of them. How many are going to score between 10 and 12? 34% of them. So, when you're looking for percentages between these numbers, you use that table from the back of your book that I just copied so you wouldn't have to keep flipping back there all the time to look at it. So what about 13? So let's change this score to 13. Then it's 13 minus the mean divided by 2. What's 13 minus 10? 3. What's 3 divide? Okay, now let's look to see where that is. Where's 13? Right here. See that? On my line, 13 would be right there. Okay, 13 minus 10 is 3. That's 1.5. So, where would 1.5 be on this line? Go down the left-hand column to 1.5, and then after that's a 0. Go across the top to 0, and what do you get? .433. You see that? If 14 would be 0.34 and this, that would be 0.475. But right here at 13 is 0.433. In other words, how many people are going to score between, out of 100, how many people are going to score between 10 and 13? 43.3%. So you've got this big chart that shows these numbers, but if you ask questions about numbers in between, you need this chart to calculate the percentages or the probabilities of a score being in that range. So what's the next one? 14.2. So we change this to 14.2. And what's 14.2 minus 10? 4.2 divided by 2, 2.1. So we come down here and we look at 2.10, and what's the number?
Do you just always use the 0 column? You know
No. What if it would have come out to be 2.14?
No. Yeah. So then you go down to 2.14, but then
No, there is no down to 2.14. You go down to 2.1 on the chart, and then go across to 4.
Huh? What?
Across the top.
Oh, so it has to do with that second decimal?
Right.
Oh.
This much goes
Why
down
is
the
it
left.
that way? That's weird.
This one goes across the top.
Why?
Because that's the way they made the chart.
That's weird.
It is not for us to question why. It is just for us to
I have my doubts.
do or die. So all these are coming out with 0, but you could have one that comes out with that other numeral there. So for 14.2, which would be about right here, wouldn't it? The z-score is 2.1, which comes out to be 0.482. Now see, all they want you to do for 16 is just find the z-score. But if I just had you find the z-score and stop, you would be going, why are we finding z-scores? And what does it say a z-score is? The number of standard deviations that a score is above the mean. And it's 0.482 standard deviations above the mean. I'm sorry, it's 2.1 standard, 2.1 standard deviations above the mean, and the probability of that score is 0.482, or from here to here on the curve is 0.482, or 48% of the people who take the test will score between 10 and 14.2. In fact, if you add the other 50%, 98.2% of the people will score 14.2 or below. Did you hear what I just said?
Not really.
Okay. 14.2 is this score. From the mean, 48%. But if you take all the ones below here, that's another 50%. So 50% plus 48%, 98% of the people who took this test scored below 14.2. Or only 2% of the people scored above it.
What do you do when the number is too big to be on the chart?
Well, you mean when you calculate the z-score?
Yeah.
That
Like-
won't happen.
Yeah, in problem 15.
15?
B.
Okay.
In a certain normal distribution, the mean is 5, and the standard deviation is
Wait.
1.25.
Wait, what number do you subtract?
What
I
number do
don't
you
understand.
subtract?
Yeah.
The mean, the z-score, minus the mean,
Okay.
divided by the standard deviation. So do we need to work that one you're looking at?
Maybe.
Number 15? 15, which one? A, B, or
15
C?
B.
C?
B.
B. 7?
Yeah.
So I go 7 minus what?
5?
The mean is
No.
5.
Yeah.
Yeah.
So I
Oh my
7
God.
minus 5 is 2. And I divide that by
Oh, okay. I didn't.
2 divided by what?
Were you doing 10?
The standard deviation.
I don't.
1.25.
Yep. I see.
And
now.
I get 1.6. Oh.
Mhm.
So guess what? The answer to your question is what happens if you get a z-score that isn't on the chart? You recalculate your z-score because you made a mistake. Good. Okay, now this comes to the fun part of it. Let's erase
That's about this.
this stuff
It's
here.
fine. I think I got it. No.
Let's erase this stuff here. Let's erase this stuff here. Let's erase this little X here. Let's erase this little X here. And let's come down here and work another problem. Oh, let's just erase all of this. Because there's your reference material. Now, problem number 18. Juan scored 88 on a Spanish test and 90 on algebra. So Spanish, his score was 88. Algebra, his score was 90. Is that what they said? For number 18?
Mm-hmm.
Now watch this. If the mean on the Spanish test was 78, so for Spanish, the mean was 78 and a standard deviation was what?
7.5.
7.5. And for algebra, the mean was what? You're not going to tell me. The mean was 82. And the standard deviation was 6.5. Okay? Now, did he do better on his Spanish or his algebra?
Algebra.
That's what it looks like, but watch this. the z-score for Spanish is his score, 88, minus 78 divided by 7.5, right?
Mm-hmm.
So do the math. Calculate that and tell me what you get.
Okay.
88 minus 78 divided by 7.5 equals
1.33333.
1.33.
Mm-hmm.
Let's do his algebra z-score. 90 minus what? 82 divided by 6.5. 90 minus 82 divided by 6.5 equals 1.23 is his z-score. So, watch what that just told us. On his math, he was 1.23 standard deviations above the mean. Okay?
Mm-hmm.
In Spanish, he was 1.33 standard deviations above the mean. So where is his score higher on the normal curve? For Spanish or for algebra? Here he is for Spanish right here,
Mm-hmm.
and here he is for algebra. I'll put the letters here. Here's his Spanish score, and here's his algebra score. Where did he do better?
Spanish.
In Spanish.
Hmm.
Because the class average for algebra was 82, while the average for Spanish was only 78.
Mm-hmm.
So that makes his score of 88, see, 10 points above the average. 90 here, it's only 8 points above the average.
Okay.
So for problem 17, you have to do that same kind of calculation to see which score was better. In problems 19 through 23, assume a normal distributed set of test scores with a mean of 100 and a standard deviation of 15. So I erase all of this. And what do I put up here? A mean of 100, and what was the standard deviation? 15? Is that what they said? For problems 19 to 23? So if this is 100, what's this one? 115. What's this one? 130. What's this one? 145. What's this one? 85. What's this one? 70. What's this one? 55. Excuse me. Do you see where I'm getting my numbers? Do you see what's
Yeah.
going on?
Kind of.
Now, do you see where I got this information from reading the information is for problems 19 through 23? It's normally distributed with a mean of 100. So 100 goes right in the middle, and a standard deviation of 15. So that means I add 15 points, 30 points, 45 points, subtract 15, subtract 30, subtract 45 from the mean. So now, for problem number 20? Oh, let's do number 19.
That'd be great.
Find the probability that a person selected at random will have a score between 100 and 110. Okay, here's 100. 110 would be right there. So, what's the probability of scoring between 100 and 110? So what's the z-score for 100? (100) minus the mean divided by 15, 0. So the z-score for, you say, yeah, because it's right there at the mean. Okay? What's the z-score for 110? What's 110 minus 100? 10. What's 10 divided by 15? 10 divided by 15 is 0.666. So, what's the question they're asking?
Find the probability that a person will selected at random will have a score between 100 and 100.
I get my probability chart out here,
Uh-huh.
and I go down to 0.66 or 0.6, and then I go across to what?
6.
I go across to 6, and what number do I get?
0.245.
0.245. But if that's a 6 and I round it to 7, then I get what?
0.249.
So which is the correct answer? 0.245 or 0.249?
0.249.
See, that's what I say too, Celeste. But sometimes the answer key says 0.245. So if your answer, because if we're doing this rounding thing, if you said, okay, so if my answer doesn't match theirs, I look back to see, oh, they didn't round it up.
Mm-hmm.
They just left it at 0.66. So what does this tell us? What's the probability of having a score?
24.5.
24.5% of having a score between 100 and 110. Between 100 and 115 is 34%, isn't it?
Mm-hmm.
But between 100 and 110, it's 24%.
Mm-hmm.
Do you follow that?
Mm-hmm.
So what's the next thing say? Between 100 and 130? Oh, that's nice. Since it said between 100 and 130, I don't have to do all this stuff. I mean, you can.
Mm-hmm.
Let's go ahead and do it just for fun. Okay, we know that's 0, so we go 130 minus 100 divided by 15 equals 2. So go down here to your chart and look at 2.00, and what do you get? 4.477. Okay, add 0.34 plus 0.135, and what do you get? 0.475.
Mm-hmm.
See that? So this is a good one. Number 22. Find the probability the person selected at random will have a score between 70. No, that's no good. They're all too easy. More than 80? Yeah, that's a good one. Let's have one that says it's more than 80. Here's 80. And more than 80. Okay, now from here on up, from the mean on up, that's 50%.
Yes.
Agreed?
Yes.
So from 80 to 100, what percent will that be? Well, the z-score would be 80 minus 100 divided by 15. That's negative 20 divided by 15. What does that come out to be? What's 20 divided by 15? .333. And what does my chart say? 1.3 and then over to 3 would be 0.408. So what percent goes in here? 41%. Just moving that over. 40.8 is about 41%. So what percent of the people are going to score above 80? This 41% plus this 50, 91%. Or the answer key might say 90.8%. You follow that?
Yeah.
So if I'm close to their answer, I'm not going to think I missed it. It's just a matter of I rounded off and they didn't.
Okay.
So what that means is the people who scored down here below 80 would be 91 from 100, 9% scored below 80. Do you follow that?
But I don't understand how to find the less than 60% on problem 21.
The what?
How do you find then if it's less than, like if they got a score less than 60%?
Okay, let's erase this and do it. So here's 60, and you want to go less than 60. So we go, the z-score would be 60 minus 100 divided by 15, right? And that comes out to be what? 40 divided by 15 equals 2.666, and that's negative. So I go down my chart to 2.6 and then across to 6.496. So the probability from here to here is 0.496. Agreed? So if this is 0.496, what would this be right here? If the whole half is 50%.
Oh, it would be.
It would be 0.500 minus 0.496.
So that'd be 0.004.
0.004. Because remember, from here, below 70, this was 60, was right here. Below 70 is 0.025. And see how it curves down like this? So 60 is 0.004. Because this is a negative 2.6 standard deviations below the mean. 1, 2, and 6/10 of another one.
Mm-hmm. Okay.
Let's see if it works doing it another way, if you don't like this. 2.6 below the mean would be right here. So what's the furthest it goes? 3.2. So subtract 2.6 from 3.2 and you get 2.6 from 3.2. Let's see, that would be 6.5 would be 19% probability. Well, .191 probability. 0.496, 2.66, 0.49, 6. Yeah, that should be right, 0.04. So maybe you better just keep working them that way. Not trying to take a shortcut. So, where do we go? Stop when you get it, problem 35. And that should take care of helping you understand normal distributions, z-scores, and distribution of z-scores, or the probability of a person being selected at random having that score. And I guess we're finished. I can't believe we went that much over time.